Today we've been asked to simplify some problems involving complex numbers. First of all, a complex number is when you have a real and an imaginary part. And so if you look at our very first problem here, we have 3 plus 8i, a real part plus an imaginary part makes a complex number. And we're taking this complex number and we're subtracting 2 minus 5i. So we're taking this complex number minus this complex number. Now, there's a real simple trick to these, which is to combine the real parts and the imaginary parts. Well, the big deal here is we're saying 3 minus 2, and we're saying 8 minus negative 5. And so what I like to do is distribute this negative and rewrite this problem. And I get 3 plus 8i, and negative 1 times 2 is minus 2, and negative times negative makes positive 5i. And then from here I just combine like terms. What is 3 minus 2? 1. What is 8 plus 5? 13i. And that's our answer. Really, this is more an exercise in combining like terms than anything else. When you have two complex numbers, you combine the reals, you combine the imaginaries, and that answer is the complex solution. That's your complex answer. Okay? Here we have an addition problem. Well, if we distribute this plus sign, a positive 1 times 7 and positive 1 times negative 5, we get 4 minus 3i. Positive 1 times 7 is plus 7, and positive 1 times negative 5 is negative 5i. What is 4 plus 7? It's 11. And what is negative 3 minus 5? Is negative 8i. And there is our complex number answer. Okay? Third problem's a little different. Now instead of subtracting or adding, now we're multiplying. We have 3 plus 2i, which is a complex number, times 4 plus 3i, which is also a complex number. Well, the simplest way to do this is it's like multiplying a polynomial. Treat this I just like it were an x or a y or an a or a b. Treat it like a variable. And if you had to multiply 3 plus 2x times 4 plus 3x, you would distribute. So what I get is I get 3 times, I take this number, this first term, and I distribute it to everything in the second polynomial, 4 plus 3i. And then I take this second term, 2i times 4 plus 3i. And some of you may have learned to do this a different way. It's called the FOIL method, and that's fine. Well, 3 times 4 is 12. And 3 times 3i is 9i. And 2i times 4 is 8i. And 2i times 3i is 6i squared. Now, first things first, we want to combine like terms. 8i and 9i are like terms. Those can be combined. But the other thing is this I squared. You have to remember that I squared equals negative 1. So this is really the same as 6 times negative 1, which makes it negative 6. Well, if this quantity here is negative 6, then 12 and that are also like terms. Well, 12 minus 6 is 6, and 8i plus 9i is 17i, and that's our answer. So again, 12 minus 6 is 6, that's the real part, and then 8i plus 9i makes 17i. Okay, let's do another one of those, another multiplication problem. So here we have a multiplication problem, same type of thing. We've got 7 minus 2i, a complex number, times 5 plus 6i, another complex number. Again, you're going to take this first term times the entire second binomial, 5 plus 6i. And you're going to take this term, negative 2i, times 5 plus 6i. And write these out. Well, 7 times 5 is 35. 7 times 6i is 42i. And then you have negative 2 times 5 will be negative 10i. And negative 2 times 6 is negative 12. And I times I is I squared. And I'll point out again, you have to remember that I squared equals negative 1. This is so important. And so in this case, this is really negative 1. Well, what is negative 12 times negative 1? Well, negative 12 times negative 1 is going to be the same as plus 12. So that whole quantity is really plus 12. So now you need to combine like terms. What is 35 plus 12? 47. And then 42i minus 10i. Well, 42 minus 10 is 32i. So your answer is 47 plus 32i. Last question here, instead of addition or subtraction or multiplication, is division. Now, you can't actually divide with complex numbers, although that's what we call it. We call it division, but really what we're doing is we're saying this I is defined as the square root of negative 1. So if you have an I in the denominator, you are dividing by a radical. We have to rationalize our denominator. Well, how do you get rid of, if this were 4 minus 5 root negative 1, the way you would get rid of that is you would multiply by the conjugate. Well, we have a fancy thing in mathematics called the complex conjugate, and that is basically the same way that you get rid of a radical. If this quantity here were a radical, to get rid of it, you would multiply by 4 plus 5 square root of negative 1. Because that's the conjugate. Well, to get rid of an I in the denominator, you multiply by the complex conjugate, which is 4 plus 5i. If you multiply the bottom of the fraction by 4 plus 5i, you're going to multiply the top of the fraction by 4 plus 5i. Now, the bottom is real simple. And I'm going to show all my work here, but the bottom is real simple. 4 times 4 is 16. 4 times 5i is 20i. Negative 5i times 4 is negative 20i. And you'll notice that these two will cancel each other out. And then negative 5i times positive 5i is minus 25i squared. Okay? And then on top, same thing, 3 times 2 is 12. 3 times 5i is 15i. 2i times 4 is 8i. And 2i times 5i is 10i squared. Now, on top, we have like terms, and on bottom, we have like terms. On top, we have 15i and 8i. Those are like terms. And we also have 12 and 10i squared. Now, why are those like terms? Well, remember, I squared is negative 1. What is negative 1 times 10? How about negative 10? That's really what that is negative 10. So you have to ask yourself, what is 12 plus negative 10? And it's 2. And then 15i plus 8i should give you 23i. Now go to the bottom. 20i minus 20i cancels. Remember, this I squared is negative 1. So what is negative 25 times negative 1? Well, it's positive 25. What is 16 plus 25? The answer, 41. And since these cancel and these add up to 41, ta-da, you're done. And that would be your answer. You didn't technically divide. All you technically did was get the imaginary part out of the denominator, therefore rationalizing the denominator. So when you see these division problems, really all you need to do is multiply by the complex conjugate and get the imaginary part out of the denominator. Okay? So this is addition, subtraction, multiplication, and division with complex numbers. If you have any questions, please come see me.